फ्रेंड्स, सब्सक्राइब टू चैनल एंड क्लिक द बेल आइकन फॉर द लेटेस्ट अपडेट। आज हम क्वांटिटेटिव एप्टीट्यूड की क्लास करने वाले हैं, जो कि आपका क्लास नंबर 7 है। ऑलरेडी हम 6 क्लासेस कर चुके हैं, जिसमें हम अरिथमेटिक एबिलिटी एंड दिस इज ऑपरेशंस ऑन नंबर्स वी हैड कंप्लीटेड एंड वी had covered up near about 200 questions. So today we'll discuss about it, where we had to discuss 185 questions of the sessions, and now we'll discuss about the second topic, which is your HCF and LCM of numbers that we'll discuss here. So SCF and LCMs of the numbers, that what we have to discuss as well, and that is also an important one if I'm talking about in terms of it. So here we'll have to first discuss about the important facts and that formula which is using in terms of LCM and SCF of the numbers. Before starting with this, first of all, it's a huge request from my side to all the viewers, please go through with the subscribe button and please like, share and subscribe our channel, so that many and maximum people can get the information at once, and even though you can also enjoy the video as well. So here we go ahead. First of all, we have to know the factors and multiples. Factors and multiples. So in terms of factors and multiples, here in this, that if a number a divides another number b exactly, we say that a is a factor of b. In this case, b is called a multiple of a here. तो अगर कोई एक नंबर है जो एग्जैक्टली डिवाइड कर देता है, एग्जैक्टली डिवाइड कर रहा है दूसरे नंबर को, देन दैट इज़ द फैक्टर ऑफ दैट पर्टिकुलर नंबर, and that the number which had been divided, so that is their multiple. So I repeat it, that if the number a is divide another number b exactly, we say that a is a factor of b, and in the case b is called as multiple of a here. The next we'll discuss about the highest common factor, which is your HCF here. HCF stands for highest common factor, which is HCF. It could be said as greatest common measure. Greatest common measure में भी पूछ सकते हैं वो, which is stands for GCM, or they can say you greatest common divisor. तो वो आपसे किसी भी वर्ड्स में पूछ सकते हैं, that is GCD. Either they can ask you highest common factor, which is SCF, greatest common measure, which is GCM, or greatest common divisor, which is GCD. This all are same in this, that the SCF of the two or more than two numbers is the greatest number that divide each of them exactly. So there are the two methods of finding the SCF of the given set of number. The first method is your factorization method. In factorization method here, that expresses each one of the given number as a product of prime factor and the product of least power of common prime factor, that gives SCF here. The second we have is the second method is your division method. In the division method here, suppose we have to find the SCF of two given numbers, that you have to divide the larger number by the smaller one, and now divide the divisor by the remainder, then repeat the process of dividing the preceding number by the remainder, last obtain till 0 is obtained as remainder, so the last divisor is called as SCF here in this. Now we'll discuss finding the SCF of more than two numbers. अगर दो से ज़्यादा numbers है, then how you will find out the SCF here, which is finding the SCF of more than two numbers. So here, that suppose we have to find the SCF of three numbers, then SCF that of any two numbers, and the third number, then similar that gives SCF of the three given number. We have to find like that only, and that similarly the SCF of more than three numbers that may be obtained. Like अगर 3 नंबर है तो पहले आप SCF दो नंबर किसी भी दो नंबर का निकाल लेंगे और थर्ड नंबर का फिर निकाल के तब आप उसको निकाल सकते हैं. Then will you combine with that, and after that अगर दो से ज़्यादा है तो ऐसे दो दो करके निकालेंगे, फिर combinedly उसको हम निकालेंगे. We'll find out the SCF here as well. Now we'll talk about the least common multiple, which is your LCM. Least common multiple, which is your LCM. So least common multiple, if I'm talking about, which is termed as LCM here. In terms of LCM, that the least common number which is exactly divisible by each one of the given number is called their LCM. In the same cases that it has been also been find it out by the two method, which is the factorization method of finding LCM, and the second is the common division method, which is your shortcut method of finding the LCM. So let's go ahead with the two methods here as well. The first we have factorization method of finding LCM. In this, that resolve each one of the given numbers into a product of prime factor, then LCM is the product of the highest power of all the factors here. The second method we have is your common division method. Common division method, which is known as shortcut method of finding LCM here. So here that arrange the given numbers in a row in any order and divide by a number which divide exactly at least two of the given numbers and carry forward the number which are not divisible. Repeat the above process till no two of the numbers are divisible by the same number except one. The product of the divisor and the undivided number is the same as expected one, and the product of the divisor and the undivided number is the required LCM of the given number here. Now we'll discuss about product of the two numbers that is equals to. So what it will be having a formula here. Product of two numbers equals to product of their SCF and LCM. Now we'll talk about the co-primes here. So that is another topic we'll have to discuss, and that is your co-prime. In co-prime, there the two numbers are said to be co-prime if their SCF is 1. अगर उनका दोनों नंबर का अगर SCF आपका 1 है तो then they are said to be as co-prime here. Now we'll discuss SCF and LCM of fraction. SCF and LCM of fractions here. In this, that we have a first formula for them, that is your SCF equals to SCF of numerators upon LCM of denominators. And when we find out the second one, which is your LCM equals to LCM of numerators upon SCF of denominators. In the same case, we now will discuss about SCF and LCM of decimal fraction. SCF and LCM of decimal fraction will talk about. In this, that in a given number, make the same number of decimal places by that annexing the zeros in some members, and if necessary considering these numbers without decimal point, and find SCF or LCM as the case may be. And now in the result, mark off as many decimal places as there are in each of the given numbers as well. Now we'll discuss about the comparisons of fractions. In comparisons of fractions here, you have to find the LCM of the denominators of the given fraction, that convert each of the fraction into an equivalent fraction with LCM as denominator by multiplying both the numerator and denominator by their same number. The resultant fraction with the greatest numerator is the greatest here. Now we'll go ahead with the question that what we have to talk about it. The first question of the session in terms of LCM and SCF of the number. You have to be very careful about while you are going through with that, because these were the questions which has been asked in many times in the examination paper. The question is find the SCF of, तो हमें SCF किसका फाइंड करना है, 2 power 3 multiply 3 power 2 multiply 5 multiply 7 power 4, then 2 power 2 multiply 3 power 5 multiply 5 power 2 multiply 7 power 8, and then the other number we have 2 power 3 multiply 5 power 3 multiply 7 power 2 here. So according to these particular question we have to solve it out. So I repeat, we have to find the SCF of 2 power 3, 3 power 2 and 5 here itself, and 7 power 4. Then the other number, the other we have is your, which is 2 power 2, 3 power 5, 5 power 2 and 7 power 8. Third number is 2 power 3, 5 power 3 and 7 power 2 as well. In the same case, we'll have to find out the prime numbers common to a given numbers that we have. As you can see, this is, we have 2, 5 and 7. We have a common prime number here. Okay, so what we have, the prime numbers common to given numbers, which is are 2, 5 and 7. In the same case, the SCF for that is what we have 2 power 2, क्योंकि यहाँ पे 2 power 3 है, यहाँ पे 2 power 2 है, यहाँ पे भी 2 power that we have 3, तो सबसे छोटा 2 क्या है, that is 2 power 2. The other we have a 3. Let's go ahead with the 3 as well, and that the 3 we don't have, that 5 we have. So for 5 की power यहाँ पे 1 है, यहाँ पे आपकी 2 है और यहाँ पे आपकी 3 है, तो 1 is the least. We'll take that 5 power 1 here itself, and that is, you can write simply 5 as well. And talking about 7, so 7 what we have, यहाँ पे 4 है, यहाँ पे आपका 8 है, यहाँ पे 2 है, तो सबसे lowest 2 है, तो we'll take 2 as well. And so in that we'll multiply it out, and 2 2s are 4 and 4 5s are 20 and 7 7s are 49. The 49 20s are, so we'll just go ahead. First we'll put a 0 here, then 2 9 the 18 8 यहाँ 1 carry, 2 2s are 2 4s are 8 plus 1 9, so that is 980. The answer will be 980. So you have to solve it like that. The answer is 980. Let's go ahead with other question, which is the second question of the session of LCM and SCF and LCM of a number. The second question we have, which is find the SCF of, हमें SCF किसका निकालना है, of 108, 288 and 360. Let's go ahead, and that what we have to solve it out as well. So here in this, that is 108 की अगर हम बात करते हैं, we will just separate it out by 2 power 2 into 3 power 3, that is 2 2s are 4 and 3 3s are 9, 9 3s are 27, 27 4s are, we have got 108. For 288 it will be 2 power 5 into 3 power 2, and for 360 you just find it out by using an SCF method. 360 is equals to 2 power 3 into 5 into 3 power 2. Then for that we have a common here 2 3, and that is here is 2 2 3 and there 2 3 5, so we'll take only 2 3. So because SCF that is the highest common factor. 2 power यहाँ पे आपकी 2 है, यहाँ पे 5 है और यहाँ पे 3 है, तो we'll take 2. इंटू 3 में यहाँ पे 3 है, यहाँ पे 2 है और यहाँ पे भी 2 है, तो विल टेक 2. 3 3s are 9 and 2 2s are 4, 9 4s are 36. You know very well, so that will be the right answer here for the question. Let's go ahead with other question, which is the third question of the session, and that is find the SCF of. आपको find करना है SCF and SCF of number we have 513, 1134 and 1215. So we'll just solve it out for this, and that is also an important one here. So let's go ahead, we'll solve it out sidewise. That is we have 1 1 3 4, 1 1 3 4 को हम 1 2 1 5 से करेंगे, 1 2 1 5. So 1 1 3 4 1 is your 1 1 3 4 itself. We'll minus it out. We will get 5 में 4 गया is your 1, and 1 में 3 जाएगा नहीं, we'll take a carry. So 11 में 3 गया is your 8, and 11 में 11 गया 0, so we'll get 81 here. फिर 81 को हम फिर से करेंगे सॉल्व 1 1 3 4 से. So 181 1 is your 81. 113 में जब माइनस करेंगे, 3 में 1 गया is your 2, 11 में 8 गया is your 9 10 11, so that is 3. So we'll take as 4 here, and when 81 of 4s that is your 324. So it will give you the answer. So SCF of, just write it down, SCF of 1134, that is 1134 and 1215 is 81. Now required SCF, that is equals to the SCF of 513 and 81. We will solve it out, so we'll go ahead. Required SCF equals to SCF of 513 and 81. So we'll solve for them as well. This is your 81, this is your 513. So 81 6 is your 486. Minus it out. 13 में 6 क्या is your 7, and then we have 10 में 8 क्या is 2, and 4 में 4 क्या 0. So it will be your 27. फिर हम 81 को लेंगे, it will be 81. So 27 3s is your 81. We'll subtract it out, we'll get it here. So the SCF of a given number is SCF of given number equals to 27. Now we'll go ahead with other question, that is the fourth question of the session, and the question we have reduce 391 upon 667 to lowest term. So the SCF of 391 and 667, we'll talk about it. SCF of 391 and 667 is 23, and on dividing the numerator and denominator by 23, on dividing the numerator and denominator by 23, we get 391 upon 667, which is equals to 391 into 23, divided by 23 upon 667 divided by 23. When we will divide 23 by 1391, we will get 17. 23 17 is 391, and 23 29 is 661. So answer will be 17 upon 29. That will be the right answer for this question here. Let's go ahead with other one, which is your fifth question of the session, that what we have to talk about it. The fifth question of the session here we will be having, and that is to find the LCM of, which is 2 power 2 cross 3 power 3 multiply 5 multiply 7 power 2. then 2 power 3 multiply 3 power 2 multiply 5 power 2 multiply 7 power 4, 2 into 3 into 5 power 3 into 7 into 11. So here we'll find out for the LCM here, and that is LCM equals to product of highest powers of 2, 3, 5, 7 and 11, which is equals to 2 power 3 into 3 power 3 into 5 power 3 into 7 power 4 into 11. That is we have, as you can see, which is your 2 power 3 because इधर 2 है and sorry 2 power 2 that we have here, which is 2 power 2 है, यहाँ पे 3 है और यहाँ पे आपका 1 है, single 1 power है. So in the same case we had take for 11 if I'm talking about, and these numbers, so that is 2 power 3 and 3 power 3, 2 power 3, 3 power 3, 5 power 3, 7 power 4 and 11 here itself. That is your LCM of the product of the highest power. तो यहाँ पे LCM में हम highest power लेते हैं, and that is the highest power we have 2 power 3 here. Here 7 में 7 की power 4 है, and 3 में we have 3 power 3, 5 पे we have 7 की 5 power 3. So the highest power will take it, then we'll find out the LCM of these numbers here. That is the products of the highest power of 2, 3, 5, 7 and 11. Let's go ahead with other question which we have is your that is your 6th question of the session. The question is, find the LCM of 72, 108 and 2100 here. So in these, for the 72 equals to 2 power 3 into 3 power 2, 108 के लिए that is 3 power 3 into 2 power 2, and for 2100 के लिए 2 power 2 into 5 power 2 into 3 into 7 here. And for that LCM equals to 2 power 3 into 3 power 3 into 5 power 2 into 7. And when we'll go ahead with the multiplication, 2 2s are 4, 4 2s are 8, and then 3 3s are 9, 9 is 27, 5 5 is 25 and 7. When we'll multiply all, just go ahead. So 2 2s are 4, 4 2s are 8, 8 and 3 3s are 9, and 9 3s are 27, 27 8s are, so 27 8s are, we'll go ahead, and that is the 56 6 यहाँ 5 carry to the 16 17 18 19 20 21 21 हो गया. अब आता है 5 5 the 25, will multiply 25 here, that is your 5 6 the 30, 0 यहाँ 3 carry, 5 1 the 5 plus 3 8, 5 2 the 10. Then for 2 that is your 2 6 the 12, 2 यहाँ 1 carry, and that is we have 2 2 on the 2, and that is your 2 on the 2 and plus 1 3 and 2 to the 4. So 0 0 1 the 4, and that is your we have 5 plus 5. So 5400, and 5400 में भी हमको next क्या multiply करना है. We have 11 7 here as well, so we'll multiply 7 as well. So 0 0, and then we have here which is 7 4 the 28, 8 यहाँ 2 carry, 7 1 5 the 35, 36 and 37. So 3 that is your will get here 37,800. So the answer will be 37,800. That will be the right answer here is for this question. Let's go ahead with the 7th question of the session here, and that we have, that is the find the LCM of 16, 24, 36 and 54 here. LCM of 16, 24, 36 and 54. So we go ahead here for this. So with 2 8 is 16, 2 12s are 24, 2 18s are 36, and 2 27s are 54. For 2 again, 2 2s are 2 4s are 8, 2 6s are 12, 2 9s are 18, एंड 2 27 ऐसे रहेगा. 2 के टेबल में 27 नहीं आता है. 2 2s are 4, 2 3s are 6, एंड 2 9 तो ऐसे ही रहेगा, एंड 27 भी ऐसे ही रहेगा. देन अगेन वी हैव 3 हियर, दैट इज़ योर 2 ऐसे ही रहेगा. 1s are 3, 3 3s are 9, 3 9s are 27. देन यू टेक 3 एज वेल, विल गेट 2 ऐसे ही रहेगा, 1 ऐसे ही है, 3 1s are 3, and 3 3s are 9. So what we will get here in the form of LCM equals to, we have 3 times 2 and 2 times 3, and then we have 2 and 3 here itself. So here that is we have 3 times 2, 2 3 into 2 times 3, 3 into 3, and 1 times 2 and 1 times 3 as well. So in the same case we'll multiply, and 2 2s are 4, 4 2s are 8, and 3 3s are 9. So that is your 8 is 9, that is your 72. 72 to 72 6, 72 6 will go ahead. I will do it here only. 72 6, 6 2s are 12, 2 यहाँ 1 carry, 7 6 are 42 plus 1 43. So we'll get 432. The answer would be your 432 here. Now we'll go ahead with other question that what we have to discuss here, which is your 8th question of the session here. So find the SCF and LCM of, हमें दोनों ही find करना है, SCF and LCM of. Number we have here is your 2 by 3, 8 by 9, 16 by 81, and 10 by 27 here itself. And in the same pattern what they are following here, we have to solve it out. For the SCM of the given formula, the given fractions we have, as we had done here, and I had told you about the formula as well. So that is SCM of given fraction equals to SCF of 2, 8, 16, 10, that we have numerator, upon LCM of 3, 9, 81, 27, that is of denominator. So here we have 2 upon 81. Now we will go ahead with LCM here, that is we have LCM of given fraction, that is equals to LCM of 2, 8, 16, 10 upon, that is your SCF of, that is 3, 9, 81, 27. So that we have 80 upon 3. That will be the right answer for this question, as well as you can see here. Now we'll go ahead with other question, which is your 9th questions of the session, and the question where we have, and that is the SCF of that is SCF and LCM of, we have to find out for 0.63 and 1.05 and 2.1 here. So here we go ahead, SCF and LCM of 0.63, 1.05 and 2.1. So here, making the same number of decimal places, the given numbers are 0.63 as 1.05 and 2.10 as well. So because these have 2 decimal places after the decimal, so we'll just make it a 2.10 here itself. So without decimal places, these number would be 63, 105 and 210. अगर डेसिमल के प्लेस के बगैर बताएं तो ये हमारा 63 है, and that is your the 63, 105 and as well as that is 210 here, that is here. So SCF of, for that we'll find it out. SCF of 63, 105 and 210 is 21. So here in the case for SCF of that is SCF of 0.63, and 1.05 and 2.1, we have 0.21. Okay, so the LCM for that, LCM of 63, 105 and 210, we have 630. So for LCM for this point we have here, that is LCM of 0.63, 1.05 and 2.1 is 6.30. So that will be the right answer. So according to the question what they had demanded, you have to act on it and you have to answer it accordingly. Let's go ahead with a further question that what we have to discuss is your 10th question of this session, even though which is also very important here with the respect towards the SCF and the LCMs of number that we solved it out, which has been asked in the competition paper as well. Thank you. So let's go ahead with 10th question of the session here. So the 10th question of the session we have, and the question is that two numbers are in the ratio of 15:11, and if their SCF is 13, then you have to find the number, and that I will go ahead with the question here. Two numbers are in the ratio 15:11 if their HCF is 13, then find the number. So here we go ahead with the solution. This is the question that what we have to deal with it, and the solution for this we have, as we know, let the required number be 15x and 11x that we have in ratio here. So let the required number be 15x and 11x. In the same case, then their SCF is x, of course. SCF is x. So where we can say that x equals to 13, and that is the number that would we have here, and that is you will multiply 15 into 13 and of course the 11 into 13, because they had given you the SCF is 13. So let's the numbers are 15 into 13. So 15 into 13 we have 195, and 11 into 13 we have 143. So the numbers we have is your 195 and 143. These were the two numbers that we have to go ahead. Okay, and now we'll go ahead with 11th question of the session, that what we have to talk about it, even though that what we have to discuss here. Let's go ahead with 11th question of the session. So here how you have to find it out each and every question, that you have to see the pattern as well. In this that is the question is that the SCF of the two number is 11 and their LCM is 693. If one of the numbers is 77, you have to find the other. So let's go ahead with the question here. The SCF of two numbers is 11 and their LCM is 693. If one of the numbers is 77, find the other. So we have to find the other here, and that the other number will find it out, which we have other number equals to 11 into 693 upon 77, and that has been multiplied by 99. So that will be equals to 99, because 11 ones are 11, 11 sevens are 77, and we'll cancel it out by this. 7 ones are 7, and 7 nines are 63, and then we have that is your 6 as well. 6 and 63, that is 99. 99 ones are 99, so that will go ahead, and the answer will be 99 here itself. Let's go ahead with other question, that what we have to find it out as well, and which we have as follows, which is your 12th question of the session. So the 12th question we have, find the greatest possible length which can be used to measure exactly the length 4 meter 95 centimeter, 9 meter and 16 meter 65 centimeter. So let's go ahead. Find the greatest possible length which can be used to measure exactly the length 4 meter 95 centimeter, 9 meter, and that is your 16 meter 65 centimeter. So we'll go ahead with the solution for this, and that we have as follows. So here required length equals to Scf of 495 centimeter, 900 centimeter, and 1665 centimeter. We had converted these meters into centimeter, where 1 meter equals to 100 centimeter. So this is 400 plus 95, which is 495 centimeter. This is 9 meters, so we'll multiply by 100, that is 900 centimeter. 16 meter 1600 plus 65, that is 1665 centimeter here itself. So here we'll further solve it out as well, that is your 495 equals to 3 square into 5 into 11, and for 900 square we have 2 square, 3 square and 5 square, and for 1665 equals to 3 square into 5 into 37. So here the Scf equals to 3 square into 5 into 45. So the required length equals to 45. 3 3s are 9, 9 5s are 45. So the required length will be 45 here itself. Let's go ahead with 13th question of the session, that what we have to talk about it, and even though that what we have to discussed here, which is the 13th question. The 13th questions we have, find the greatest number which on dividing 1657 and 2037 leaves remainders, that is 8 and 5 here itself, and that is respectively. So we'll go ahead in reference towards it. So where we go ahead, and that is your 6 and 5 remainder. So let's go ahead with the question. find the greatest number which on dividing that is your 1657 and 2037 these remainders 6 and 5 respectively. So here we go, that is required number equals to SCF of 1657 minus, we have respectively the 6 remainder here minus 6 and 2037 minus 5. So with the same case we will get the answer that is equals to SCF of 57 and that is when 57 minus 6, so that will be give 1651 and that is your 2032 because we'll minus it 5 here as well. So we'll get these two numbers here. Now we will go ahead with the division method. 1651 2032, so that is 1s are 1651, we'll subtract 8 3, we'll proceed it 1651 381 4s are 1524, minus it out 7 2 1, and then we'll subtract we'll divide by 381, 127 3s are 381 and that will be cross. So the answer would be required number is your 127 equals to 127. Now we'll go ahead with other question, which is your 14th question of the session. The question is, find the largest number which divides 62, 132 and 237 to leave the same remainder in each case here. So the 14th question, as I told you that we will be go ahead here. 14th question of the session, which is find the largest number which divides, that is 62, 132 and 237 to leave the same remainder in each case. So we have the solution here as to be follows. Required number equals to SCF of 132 minus 62, 237 minus 132 and 237 minus 62, which is equals to SCF of 70, 105 and 125. So the SCF of these three numbers we have 35 here itself. Let's go ahead with the other question, which is your that is your 15th question of the session here. We'll talk about it. We'll find the least number exactly divisible by 12, 15, 20 and 27 here. So let's go ahead. Find the least number exactly divisible by 12, 15, 20 and 27. So for that we'll go ahead. Required number equals to LCM of 12, 15, 20 and 27. So we go ahead to find out the LCM for this, which is 12, 15, 20 and 27. That is 3 4s are 12, 3 5s are 15 and 20 itself remain 3 9 27. Again take 4 1s are 4, 5 remain same, 4 5s are 20 and 4 9 itself same remain here. For the 5 1 we'll take 5 1s are 5, 5 1s are 5 and 9 itself. So for that we have LCM of that equals to 3 into 4 into 5 into 9, 3 into 4 into 5 into 9, that is equals to 5 9s are 45 and 45 4th is a 12, 45 12s are. Let's go ahead. 5 2s are 10, 0 1 carry, 2 4s are 8 plus 1 9 and that is equals to 8 and 4, so 0 7 and plus 1 570, so 540, sorry, that will be 540 and 540 will be the right answer for this question as well. And in the same cases we had gone through with that 2 5 0 1 carry and that is your 4 to the 8 plus 1 9 1 8 and 4. That is 470 will be the right answer. 470 will be the right answer here for that same. Now we'll go ahead with other question, which is another one, and that is in terms of it 9 3s are, that is 27 and 27 20s are. So that is 27 20s are, we'll go ahead as well. 27 20s are 0 0 into 7 to the 14 4 यहाँ 1 carry, 2 to the 4 8.5, yeah 540 will be the right answer. Okay, 540 will be the right answer here. So you have to recheck when you are calculating the questions here. Now we'll go ahead with other one, which is your 16th question of the session. So the required number is your 540. That is another question, is your 16th question of the session. The question is, find the least number which when divided by 6 7 8 9 12 leaves the same remainder 1 in each case. So let's go ahead. Find the least number which when divided by 6 7 8 9 and 12 leaves the same remainder 1 in each case. Now for that we have a solution here that will find it out as well, which is 6 7 8 9 12. So that will go ahead. The 3 2s are 6, 7 8 remains same, 8 is remains same, 3 3s are 9 and 3 4s are 12. Then we'll take 2 1s are 2, 7 remains same, 4 2 4s are 8 and 2 3 here, and that is 2 2s are 4. We'll take again 2 1, that 7 remains same, 2 2s are 4, remain 3 itself and 2 1s are 2. So what we'll take is here is your LCM equals to 3 into 2 into 2 into 7 into 2 into 3. So let's go ahead with this, and that what we have to solve it out as well. So here that is 3 2s are 6, 6 2s are 12 here, 12 and 7 2s are 14 and 12 3s are 36. So 36 into 14, we'll go ahead with 36 into 14 here. 24, 2 carry, 4 3 is 12 plus 2, that is 14 into that is your 36, 4 and then 0, yeah, 1 carry, 3 1 plus 4 815, so 504. So the answer would be LCM is equals to 504. So as they had said that remainder 1 in each case, so for that required number equals to 504 plus 1, so that is equals to 505. That will be the right answer here. The required number is your 505. Now we'll go ahead with 17th question of the session, that what we have to talk about it here. The 17th question we have, find the largest number of 4-digit exactly divisible by 12, 15, 18 and 27. So let's go ahead with 17th question, which is find the largest number of 4-digit exactly divisible by 12, 15, 18 and 27. So the largest number of the 4-digit number we have, that is largest 4-digit number equals to 9, 9, 9 and 9, and the required number that must be divisible by the LCM that we have your, that is in reference towards 12, 15, 18, 27, and for that we have LCM of 12, 15, 18, 27 is 540, and on dividing 9999 by 540 we get, on dividing 9999, that is in the same references by 540, we get 279 as a remainder. So required number equals to 9999 minus 279, which is equals to 9720 here. Now we'll go ahead with 18th question of the session here, that has been asked. So the 18th question, find the smallest number of 5-digit exactly divisible by 16, 24, 36, 54 as well. So let's go ahead. Find the smallest number of 5-digit exactly divisible by 16, 24, 36 and 54. So the smallest number of 5-digit number that we have is 140, and that is your 10,000. A required number must be divisible by, that is your LCM of 16, 24, 36, 54, that we have is your 432. So on dividing 10,000 by 432, we get 64 as remainder, and in the same case the required number we have 10,000 minus plus 432 minus 64, so we'll get 10,368 here. That will be the right answer for this question as well. So let's go ahead with other one, that is to be the another question, which is your 19th question of the session, that what we have to talk about it. Let's go ahead here. So the 19th question we have, find the least number which when divided by 20, 25, 35 and 40 that leaves the remainder of 14, 19, 29 and 34 respectively. So we have to solve that. 19th question of the session, which is find the least number which when divided by 20, 25, 45 and 40 leaves remainder 14, 19, 29 and 34 respectively. So here we go ahead with the question solutions here. So here 20 minus 14 equals to 6, 25 minus 19 equals to 6, 35 minus 29 is equals to 6 and 40 minus 34 equals to 6. So required number equals to LCM of 20, 25, 35, 40 minus 6, which is equals to 1394. Now we'll go ahead with other question, that is your 20th question of the session. The question we have here is find the least number which when divided by 5, 6, 7 and 8 leaves as remainder 3, but when divided by 9 leaves no remainder. Let's go ahead. Find the least number which when divided by 5, 6, 7 and 8 leaves a remainder for 3, but when divided by 9 leaves no remainder. For that we will solve it out here, and that we have the LCM of 5, 6, 7, 8 equals to 840, and the required number of the form is your 840k plus 3, and in the same cases that the least value of k for each, least value of k for each that we have, for which it would be 840k plus 3 that is divisible by 9 is so that k equals to 2. So required number we have that is equals to 840 into 2 plus 3. So 840 into 2, which is 1680 and plus 3, so that is equals to 1683. That will be the right answer for this question here. Now we'll get ahead with another one, that is your 21st question of the session of SCF and LCMs of numbers here. That will go ahead. So let's go ahead with 21st question of the session. So let's go ahead with 21st question of the session that we have. The question we have, the traffic light at 3 different road crossing changes after every 48 seconds, 72 seconds and 108 seconds respectively. If they all change simultaneously at 8 hours 20 minutes 0 seconds, that is your, then at with what time will they again change simultaneously? That what we have to go ahead. Let's go ahead with the question. The traffic light at 3 different road crossing change after 48 second, 72 second and 108 second respectively, if they all change simultaneously at 8 hours 20 minutes hours, so then at what time will they again change simultaneously? So that what we have to solve it out. Let's go ahead. No, not a problem. We go ahead, like interval change, we have interval change equals to like LCM of 48, 72 and 108 seconds, which is equals to 432 seconds. In the same cases, that so the light will again change simultaneously after every 432 seconds here, and that is 7 minutes 12 seconds, which is equals to 7 minutes 12 seconds. So hence next simultaneous change will take at 8 hours 27 minutes 12 seconds hour. That is the time. This is the solution. The question is long, but you have to consider about it what they had asked you. If the concept of the questions has been clear to you, so that is the reason that you are able to do it very quickly. Otherwise you will take a time, and that makes you in a trouble, of course, if you are not having those questions cleared concepts here. So okay, so we'll go ahead with other question which we have is the 22nd question of the session as well. That is, arrange the fraction which is 17 upon 18, 31 upon 36, 43 upon 45, 59 upon 60 in ascending order. We'll go ahead. So LCM of 18, 36, 45 and 60, which is equals to 180. So now 17 upon 18 equals to, that is 1710 up into 18 into 10, which is equals to 170 upon 180. We'll find out as here. So that in the same cases we will go ahead with other one, and that what we even though have to discuss here as well, and that is your 31 upon 36. So for that 31 into 5 upon 36 into 5, which we will get 155 upon 180. Here the denominator we have to make as 180 here for all, so you have to multiply those numbers that makes the denominator 180, and the numerator whatever they can make it, it's not a compulsory, but for the denominator it is compulsory to make 180 here. What 45, that is your 43 into 4, and that for 45, which is 45 into 4, and that is equals to 172 upon 180. The other one we have 59 upon 60, which is 59 into 3 upon 60 into 3 as well, that is equals to 177 upon 180. So since 155 is less than 170 here, that is less than 172, less than 177, so we can say that 155 upon 180 is less than 170 upon 180, and that is less than 172 upon 180, and that is equal to less than upon 177 upon 180 here. So the fractions, hence the answer we have is your 31 upon 36, 17 upon 18, 43 upon 45, and 59 upon 60. So that is the order that what we have to arrange in the ascending order here itself. Let's go ahead with other question which has been asked in IGNOU, and that is in I will provide you the options as well. That is a sort of an objective wise, and you have to clear about it, that are you able to solve it out or not, and if there are any problem related to that, you can just inform me as well. Let's go ahead with a 23rd question of the session. So the question is, and that is 252 can be expressed as a product of primes. That has been asked in IGNOU, and the options we have 2 into 2 into 3 into 3 into 7. That another one we have 2 into 2 into 2 into 2, 2 into 2 into 2 into 3 into 7, 3 into 3 into 3 into 3 into 7, and 2 into 3 into 3 into 3 into 7 here. So that what we have to solve it out as well. So here we go ahead with the solution for this particular question, which is even important because this has been asked in your IGNOU examination paper. So clearly 252 is equals to 2 into 2 into 3 into 3 into 7. Okay, now we'll go ahead with other question, which is your 24th question of the session. The question is, which of the following has masked a number of divisors? So number of divisor that they have, the options I will tell you about 99. The B option is your 101, and the C option is your 176. The D option is 182. And this has been asked in the MBA examination paper, which is also an important one. So here we go ahead with further one, that is for 99, that is equals to 1 into 3 into 3 into 11. For 101, which is 1 into 101. For 176, we have 1 into 2 into 2 into that is 2 into 2 into 11. And for 182, we have 1 into 2 into 7 into 13. So the divisor of 99 we have is your 1, 3, that is your 9, and as well as 11, 33. So I'll just write it down here. Divisor of 99 or divisor of 101 or divisor of 176 R and divisor of 182 that R. So we'll go ahead for the 99. We have 1, 3, 9, 30, 9, 11, 33 and 99. Okay, for the divisor of 101 we have 1 and 101. And for 176 we have 1, 2, 4, 8, 16, 22, 44, 88 and 776. And for 182 the divisor we have 1, 2, 7, 13, 14, 26, 91 and 182. So we'll count it out. The most we have 3, 3, 6, okay, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 1, 2, 3, 4, 5, 6, 7, 8, 8 here. So that is we have here, that is your 8 here and 9 here. So the most we have is your 176. So hence 176 has the most number of divisors. So now we will go ahead with other one, that is the another question will go ahead here, and that in reference towards a question which is your the 25th question of the session, that even though we have to go ahead here. So let's go ahead with 25th question of the session. So the question we have as follows: a number pi is said to be a perfect if the sum of all the divisors excluding n itself is equals to n, and an example of a perfect number is the options we have 6, 9, 15 and 21. First we'll go ahead with the question and then we'll solve it out. A number pi is said to be perfect if the sum of all its divisor, that is excluding n itself, is equals to n, and example of perfect number is, so for that we have an option 6, 9, 15 and 21 here. And the same among these particular question we will be going ahead with the solutions here as well. So here in the same respective manner that we will be making a sort of a table here that we will be going ahead as well. So here we go, that is we have your n, this is the divisor excluding n, and sum of divisor. So for n, when equals to 6, it will be 1, 2, 3. So 3 plus 2, 4, 5 and plus 1, 6 here itself. The other number we have is your 9, which is your 1 and 3. So yes, for that the sum we have 3 plus 1 is your 4. The other number we have is your 15. For them that is 1, 3 and 5, and 5 plus 3, 8 plus 1, 9. And for 21 we have, that is your 1, 3 and 7. So that is 7 plus 3 is your 10 plus 1, 11. So the 6 is a perfect number here. We can say that clearly. 6 is perfect number. Okay, so 6 is a perfect number here. That will be the right answer for this question as well. Now we'll continue with the next coming class in the further classes that what we have. So here we'll end up with that is your quantitative aptitude, which is SCF and LCM of a number here. And here in the quantitative aptitude we have to discuss many more things in the section 1, which is your arithmetic ability, where we had completed your numbers, and as well as we had started with FCF and LCM of numbers. We will completed decimal fractions, simplifications, squares and cubes, root and average, problems on numbers, problems on ages, subs and indices, percentage, profit and loss, ratio and proportion, partnership, chain rule, time and work, pipe and cistern, time and distance, problem on trains, boards and streams, allegations on mixtures, and simple interest, compound interest, logarithm, area, volume and surface area, races and games of skills, calendars, clocks and stocks and shares, as well as permutation and combination, probability, true discount, banker's discount, height and distance, odd man out and series. In section 2 we have to discuss the data interpretation, where we will complete tabulation, bar graphs, pie chart and line graph as well. Other than the quantitative aptitude, we are dealing with reasoning, where we had covered up the verbal reasoning, as well as we had started with non-verbal reasoning, where in the non-verbal reasoning we had completed your series, and we had started with that is your analogy as well. So you can go through with that, you will find out each and every video there. We had even though started with sociology from today onwards as well. You can go through with the playlist, and many more subjects we had done, and many more subjects we have to learn. We will surely start with the chemistry and the software engineering as well in the next coming few days. So stay tuned with us, and please like, share and subscribe our channel, so that many and maximum people can get the information at once, and even though you can also enjoy the video as well. And you will be we will be provided you each and every video what you required of. You can go through with the comment section, and please inform us that which subject and which topic you have to learn about it, because we are dealing with a competition as well, that we had even though completed the verbal reasoning, and we had started with non-verbal reasoning as well. And even though we had started with your quantitative aptitude as well. So we'll deal with it, whatever the topic you will set about it. So thank you. Hope you enjoyed this video. If you like this video, please give a thumbs up and give a suggestion on a comment box. Thank you.